Alrighty. So again, we introduced this yesterday. You had like 10 minutes or so to work on it. We're going to review it, see if your answers are correct, any parts you may be confused on. But again, what we were dealing with yesterday with this problem was net distance versus total distance. And we had some formulas that we had written yesterday to deal with both net distance and total distance. And that distance, the net and total, are the same if what? Net distance and total distance are the same if what? Yeah, if it doesn't change direction. If you're going in the same direction the entire time, your net and total will be the same. If it changes direction, they will be different. So in these problems, it's important to determine whether you change direction or not. So the first step of this problem is determining net distance. So net distance, you just use your endpoints. What are your endpoints for this problem? What are your endpoints? It's going to be absolute value of p of what? Stevie?
5 pi over 4.
5 pi over 4. And then we're going to subtract away the other endpoint, p of pi over 6. Again, p for the position function, you're given the position function. After calculating these two, subtracting them, and taking the absolute value, what is your net distance value? What is your net distance value? Plug that into your position function.
0.99 feet.
Yep, I rounded to 3. Same thing though, 0.989 feet. That is the net distance, 0.989 feet. So now we need to determine the total. So first we have to determine whether it changed directions or not. So if I have a position function, how do I use it to help me determine if I change directions? Correct. Correct. So velocity is the derivative of the position. So if I take the derivative of t, I get 1. If I take the derivative of 2 sine t, what do I get? 2 cosine t. I set that equal to 0. Find your two critical points. Negative 1/2 equals cosine of t. So what value of t would be a critical point? Cosine of what equals negative 1/2? Think of your unit circle. That's Anastasia? 2 pi over 3. So we did find there is a critical point. What is important to determine is that critical point within your interval. So is that between pi over 6 and 5 pi over 4? Is 2 pi over 3 between pi over 6 and 5 pi over 4? Yes, it is. And if you are confused by this, trying to determine whether it's in between them, you could actually calculate that out mathematically and find the decimal versions just to be sure. But yes, it does fall within. So we can create our table. We go from pi over 6 to 2 pi over 3. Then we go from 2 pi over 3 to 5 pi over 6. Again, we want to know when the velocity, if it changes direction. So we need to know if it's positive or negative. So these are the intervals. We need to pick something within the interval to plug into our velocity function. So it can be anything within the interval, but try to pick something. Again, we don't care what the actual value is at the end. We just care if it's positive or negative. So there's multiple ways to do this. If you have a calculator, you could do it graphically. If you have values in between, you can just plug them directly in. But do you get positive or negative for these intervals? For the first interval, positive or negative? Daniel?
Positive.
Positive. What about the second interval? negative. So this is important to us because it's telling us the velocity had to have changed directions, because we went from a positive velocity to a negative velocity. So that tells us right there, because they're different, we know the total distance has to be different from the net distance. So we actually have to calculate it now. So total distance. We know it's going to be different now. So now we have to use that formula from the definition that we wrote yesterday. It's in your notes. We have to add all the pieces together. So the absolute value, P of 5 pi over 6 minus P of 2 pi over 3. That's the first part. So P of 5 pi over 6 minus P of 2 pi over 3. And we're going to add that to the absolute value of P of 2 pi over 3 minus P of pi over 6. So 5 pi over 6, pi over 3, 2 pi over 3, 2 pi over 3, and pi over 6. Those are the values. Again, you have to find them, subtract them, and then we're going to add these two pieces together. So if you have not done so already, take some time to plug those into your position function and find the value after you add them both together. Did anybody calculate that already? Maybe from yesterday? Daniel?
3.6157.
I agree with that. 3.617. And it is feet because it's distance. 3.617. So again, I calculated this one, subtracted from that one. Absolute value of it added to this one minus that one. Any questions? So this is the one we worked on yesterday. Ariana, is part you're confused on?
What about 5 pi over 16?
Okay, that would be 5 pi over 4, sorry. Yeah. 5 pi over 4, that's from this one up here. Yep, 5 pi over 4. So in the table, it would have also been 5 pi over 4. Thanks for catching that. Yep.
If I rounded to 3 decimals all the way through the problem and I'm off by like...
It will vary a little bit, but that's okay. How far off were you?
I have 615.
Yes, that's fine. That was just rounding error. Yep, that's okay. Any other questions? All right, so let's go ahead and move on then. So on the back, we have 2 problems left that I would like to get through today. But I kind of want to base it on how you guys kind of feel with the topic and what you'd like to try. So again, this deals with position, velocity, acceleration, so the topic we've been covering. There are A through E parts here. Is this something that you would like to try with a group of friends or as a partner, and then we'll go over the answers?
Yeah.
Okay, so give it a try. I'm going to give you quite a bit of time because this is a full problem. You have parts A through E. Get together with somebody, check some answers, make sure you're getting the same thing, but take your time and go through it. There's a lot to answer in this problem. If you want to move seats to be with somebody, you can. I don't care. Anybody have any questions? Summary part check. Remember the slope of the position. That's fine, the slope of the secant line. Yeah, but the slope of that would tell you the velocity. Yes, you found the slope of the acceleration. You want to find the slope of the velocity. The slope of the velocity uses position. E of B minus B of. Yep. You get an answer. You're really close. Let's see the work.
Oh, I just found that.
Okay. And then did you subtract that one off? So two things. One, I think you need to pay attention.
I got like negative 15 plus.
Oh, okay. When you do an average, you do P of B minus P of A over P minus A. And then there's no absolute value. That's when you find the average. P of B minus P of A over P minus A. And then it's velocity, what units be, not just speed.
3 plus plus 1.
That's acceleration. Velocity is speed. 2%.
We can't read it all.
Anybody else like the first one check at all? Give me the answer for A.
No.
Yes, yep. Careful here. We're dealing with finding average velocity, but if you think about take an average, that's like a slope of a secant line. So if we take the slope of a secant line of a velocity, so we're going to take the slope of a velocity, that's actually telling you velocity is zero on the acceleration. So we need to take the slope of the secant line of the position to tell us what the velocity.
Just to see,
Yeah.
does zero count as a positive?
Zero count as what, sorry?
Positive. B prime.
That's every velocity.
Zero. Delta prime is 10. So what I said about the speed. Would it be increasing still?
Alright, so it's a special case that you need to think about. The velocity is zero. So it's velocity, it's not moving, but you at that point in time, specifically right there. But the acceleration is positive. So what is happening at that moment? At that moment, what is happening?
Smoker.
You have a question?
Yes.
Okay, 1 second, I'll be back. minus -5, so that gives you what then?
Do you understand maximum velocity?
Units though.
It's me per second.
Oh. We do P double prime.
So, what's my name?
And then do the intervals. Which part are you on? Right? Use P double prime to find increasing and decreasing. And then find the maximum.
So, if you're trying to find a maximum velocity,
Yeah.
I think you're headed in the right direction.
Points of the acceleration.
Yes.
I think this is
So you're using the critical point, because that critical point could possibly be a risk. So you don't need to necessarily create that table. You find a critical point, you need to test that critical point and test what other points. You're trying to figure out which points are the max, yeah. And then from your endpoints and your critical points, you determine which one gives you the maximum velocity. That is correct. Now, I know every group or every pair is at a little different spot. I'm still going to give you a few more minutes because nobody's finished yet. So work through as much as you can, and then we'll start reviewing each part.
So for part B,
Yeah.
we define critical points, right?
Yes.
So did you set the velocity equation equal 0?
Very good.
Did you get 3t squared plus 2t minus 3? With your mom.
No, wait. How do you know? But that's what you do. Min is definitely.
I'm going to slowly start putting some answers up on the board for you to check with yours so you can check at your own pace. Again, if you have any questions about it, ask about it after you see the answer. If there's anything you have a question about, we'll go over that part specifically. But if somebody's done or close to done, I want you to be able to check some of it.
Minus
So if you're checking, is this part you're looking at?
Yeah.
Be careful of your critical points. So we're talking about this velocity here, but what interval are you dealing with? Well, you're dealing from 0 to infinity because you're starting at time 0. And it doesn't say when we stop. So your intervals goes from 0 to infinity. We don't have a negative time there. So yes, it's a critical point, but we're not talking about negative time. We're talking about from your starting point to infinity.
Now, average velocity equals slow flow.
Yes. I just came up. Yeah.
Anybody have any questions about this part C that's up here? That's finding p prime of 3 is 0 feet per second, p double prime of 3 was 10 feet per second squared. They wanted to know what can you tell is happening at that point. So think about that. Your velocity is 0. If your velocity is 0, think about your speed. That means your speed is 0. You're not moving. But you have acceleration. So at that moment, what's happening? Well, momentarily you're stopped and you have to be changing directions. That's what's happening. Your acceleration, you still have an acceleration, but you're not moving at that exact moment because you're changing direction. For part D, they wanted to know about maximum velocity. So if you think about maximum velocity, if you take the derivative at a maximum, what are you going to get? If you think about your maximum, a 0. So you take your derivative of your velocity, set it equal to 0, and find a critical point. Because at a maximum, you should have a derivative of 0. So again, you're going to check that point because it could be a max or a min. So not only do you have to evaluate that critical point, but you're on an interval. They specifically tell you from 1 to 3, so you need to check your endpoints. So check v of 1, check v of 3, and also check your critical point, v of 4 over 3. Those are the 3 points of the velocity that you have to check, because they could potentially, since you're on an interval, those are 3 positions that could possibly be a maximum.
We're working on a big video contest thing, so
Okay.
it took a little extra time.
They're kind of working independently or with a partner right now on the problems in the notes, and I'm just slowly putting up some answers to them. On page 302, Vinny, that's the problem we're working on. And if you would like to check if you've gotten the answer yet, try it before you look and just copy it, but the total distance at the bottom. So go ahead and try the total distance, see if you get the same answer. Again, you need to determine if it changed directions anywhere. They give you specifically an interval of 1 to 5. Well, don't overthink it too much. You already did talk about an interval 0 to infinity at the top. So you just need to figure out about from 0 to 5. So don't overthink it. Good, Stevie, or are you
I'm
confused here?
thinking out loud right now. I think I'm okay.
Remember, total distance is going to be different from net distance if you change directions. We did determine up here at one point we did change directions, so you need to use this information to help you here. But your interval is only from 1 to 5 instead of 0 to infinity. 1 to 5. Now, I know we're all in a little bit of different spots, working independently. If you're finished, do you have any questions about any specific part? All right, so what I'd like to do, if you are finished, if you're not finished, keep working. Work through it, keep checking your answers. If you are finished, we have one problem left in the notes. Again, we'll go through it, anything you have confusion on, but work with somebody. Go ahead, start the last problem on page 303. It has parts A through D, and you have a table there to use. Pay attention to all the information they give you, but try to answer as much as you can for the next one, and we'll go over it too. I'll give you a hint for part B on that second problem. You may need to think back to some of those theorems that we talked about in that last chapter. That might help you in part B of the second problem.
Second one.
Fine, this part is PFP, so plugging into the original. So at this point, you're just plugging all these in into the original one and subtracting them in this order. If you try it again and you can't get one, Thank you. Anybody still working on the first one, or can I change it? All right. I'd like you to keep working, but because of the time we have left, I'm going to continue to put some answers up for the second one. So. Again, with part B, I'd like you to try to think about it, think about the theorems we used in that last chapter. So it'll help you answer part B. If you need to look back, look back. Just a reminder, we're going to finish this up today. Your free response day will be tomorrow.
You always watch it. It's not funny. Yesterday she got you on. I was gonna let you out right there. I got 18. I was gonna let you out.
Next time it happens, just back up.
I do, and she runs to the back. I'm just gonna hit her. She got shocked when I lay on my horn. You don't expect me to do it.
C is decreasing the
The one
position.
thing Cooper Park did that one. That's it.
Make sure you finish up this problem. If you have any questions, ask. Make sure once you finish, you check your answers. Make sure they're correct. And again, if you have any questions, we'll go over any part you would like to.
Wait a second.
What about 0 to 15 for B?
Yes, you could have used that also. Yeah, for part B, you could add 0 to 15 also if you had that one. Dan, can you watch me trying to check some answers behind you? You're good.
I got a different number value for D, but it was still negative.
So, so you would have had to have taken...
The derivative, which would have been negative sine t over 10 times 1 over 10 plus free sine 7t over 40, 7 over 40.
Let me see your derivative. Be sure to check your answers before you leave.
Ariel got that one.
Yeah, we'll have to type that. I'm just typing because that's about.
Is that a 10 or
I think it's.
It's a 40. 40 on here.
Did you have 10?
No. I had a 40. I can double check. It takes a few moments to type it in. There's 23 over 10 times 1.